All right, welcome back. We're going to talk about intercepts and solutions to equations. Objective: students will be able to determine the solution of a given equation and find the missing x or y variable for a solution given the equation. Students will be able to identify and solve for intercepts from a graph, table, and equation. So let's talk about what a solution is first. A solution is a value or values we can put in place of a variable or variables, in this case it's going to be multiple variables, that make the equation true. So let's get right into it. Let's take a look at example 1 and see what I mean. So we're going to test this. We're going to determine if this is a solution. There isn't really a direction here. Maybe I should have put that in there, so let's just add that on top. Determine whether the coordinates are a solution. Or maybe I should say is a solution, but it's kind of confusing because there's two values. Anyway, we're going to check and see if -2, -12 is a solution to this equation. Now remember, they're always going to give us the x and then the y. So what I'm going to do is I'm going to plug these in. The first I'm going to plug in is the y, which is -12, equals 6 times my x plus 3, and my x is -2. And all we're doing, it's not really equal yet. Actually, what we're doing is we're asking, is this equal? Okay? Because if it's equal, then we have a solution. If it's not, then we don't have a solution. So let's play with it. Let's see what happens. Well, 6 times -2 is -12. So I have -12 equals -12 plus 3. And -12 plus 3 is -9. And so what have we determined here? We have determined that these are not equal. Therefore, that is not a solution. But let's take a look at example 2. Once again, I have an x and a y, and so I'm just going to rewrite the equation, plugging in my x and a y. This one's in the same order, so it's easy. So I like to just use parentheses for anything that I'm plugging in. It's a very good practice. So my x is 4 and my y is -2, and let's just work it out. 3 times 4 is 12. 9 times -2 is -18. I have -6, and 12 minus 18 is, in fact, -6. Therefore, this is a solution. So that's all we're doing for now. Are these solutions, yes or no? So what I want you to do is try practice 1 and 2. Just give it a shot and see if these are solutions or not. And then unpause the video when you're ready to check your work. All right, yeah, hopefully you saw that when you plugged in a 2 and a 1, 2 for x and 1 for y, this equation ended up being true. And so we can say, yes, 2, 1, that is a solution to this equation. Over here, when I plugged in 2, 2, pretty easy since they're the same. I got 10 equals 10, so that is a solution. 2, 2 is a solution to this equation. All right, next up, we're going to talk about an x-intercept. And this is simply when a line or a function of any kind crosses the x-axis. So we have a picture of it over here. And I'm going to go from the right all the way to the left on this one to talk about what that means. So all we're really asking is, when does this thing cross the x-axis? Well, if we follow this line, we can see that it crosses the x-axis right there, right? Everybody see that? You can see the point right there at -7 where it crosses the x-axis. So that would be our x-intercept. That's when it crosses the x-axis. So I just want to write down that you could say it this two ways. You could say the x-intercept is -7, or you could say it has an intercept at the point -7, 0. And the reason why we know the other coordinate will always be 0, okay? So if I'm looking for the x-intercept, the y is always going to be 0. That's very, very important. We'll come back to that actually in just a moment. But the opposite axis value will always be 0. So that's how you can tell from the graph. It's literally just when it crosses the x-axis. If you come over here, we said already, it's always when, I'm going to write this down, when the y equals 0. Important. Okay, well, we already found a part right here. The y equals 0. This is in a table now. The y equals 0 and the x is -7. Of course, this table represents this graph, and it also is represented as an equation or a function form over here. So it's all the same. So if you're looking at a table, you're just looking to find when does the y show us a 0, and therefore that x location would be our x-intercept. Again, two ways we could write it. We could write it by just saying what our x-intercept is. We could write it by saying a coordinate that represents the x-intercept. All right, what if we didn't have any of that and we had an equation? Well, again, it's when the y equals 0. And so what you're allowed to do is literally take a 0 and plug it in for y. Let me show you what I mean. I have a 2x minus 7, parentheses, and instead of y, I'm going to put a 0. And now I'm just going to solve this equation for x. And it's not too bad, because a lot of stuff's going to cancel out. The first thing you'll notice is anything times 0 is just 0. So really I have 2x minus 0 equals -14. Well, I don't need that 0 there, so this is really just like saying 2x equals -14. And then I'm going to divide both sides by 2. And I get x equals -7. And voila, there's our x-intercept. It's at -7, and of course it's when y is 0. So 3 different ways we could find it. 2 different ways you can write it. All right, let's go to the next page. Okay, so that was the x-intercept, but what about the y-intercept? In a lot of ways, the y-intercept will be a lot more useful as we go to graph lines and functions of any kind. So we'll be probably finding this more often, but for now, we're just practicing finding both. And now, the process is pretty similar, except for now, it's when the x is 0. So again, the opposite axis is 0 for whatever intercept we're trying to find. And this is pretty easy to do. So we're just trying to find when does it cross the y-axis. And we can see it right there, right? It's right there when the y value is 2. So once again, I could say either it's the y-intercept equals 2, or we could say it's the coordinate of 0, 2. Either way, we could write this. If I was to go to the table, just like we did the last time, I'm looking for when the x is 0 now, and so that's this point, 0, 2, and once again, we get the same value. And once again, let's say I was going to the equation, and I wanted to find that out. It's always when the x value is 0, and so I'm just going to replace that with a 0. Let me show you what I mean. 2. I like to do parentheses for my placeholder, minus 7y equals -14. And in place of x now, I know this is when x is 0, so I'm going to plug in a 0 there. Well, 2 times 0 is just 0, minus 7y equals -14. I don't need that. Divide both sides by -7. By the way, the reason I'm dividing is because my variable is being multiplied by -7. Right? When you're solving an equation, you're trying to undo whatever's happening to your equation. So I divide both sides by -7. That cancels out, and I'm left with y equals -14 over -7 becomes +2. And look at that. There's my y-intercept. It's at 2. Again, 2 ways we could say it. Y-intercept is 2, or the coordinate point of 0, 2. Not so bad. Pretty easy. Lots of different ways to do it. Okay. We're going to talk about this table one for a second, but I want you to know that you can't always get the information you want from a table. So we're going to get what information we can, but sometimes you're not going to be able to get it just from a table. You're going to need a little bit more work, and there's some extra tricks to that. And so if we get some hard problems like this in class, I might do an example or 2 on the board, especially if you remind me. But for the most part, we're just going to probably only be able to find one intercept from the table, and we'll have to do some extra work. And that extra work would mean that we would need to write an equation. So just kind of make a little note that sometimes you need an equation. And that's okay, because I'm going to show you how to do it from an equation next. But for now, let's talk about the table. If I take a look at number 1, we could see quite a few things going on here. Right away, maybe you're seeing what I see, and that is I see one of the intercepts right away. We know the y-intercept, because when x is 0, it's 7. The y-intercept is 7. So I got that far. I know that the y, I'm actually going to write it down here, is 7. But what I don't know is the x-intercept. And to do that, I'm going to have to kind of see if I can fill in the chart a little bit, just to see if I can find it. And you might be able to figure out what's going on here. But as I look at this chart, if I look here, it looks like as I go down, I'm just adding 1 every time, right? That's the pattern. And since I'm just adding 1 every time, I could go backwards. And I could say, you know what? Before -2 is -3. And before that is -4. And I could keep going backwards in this chart if I wanted to. Same thing over here as I go down the chart, I'm adding 2 every time. And so if I wanted to work backwards on this chart, which I do because I'm trying to find, I already found when the x is 0, I'm trying to find when the y hits 0, I could. And I would go back 2 and I'd get to a 1. I'd go back another 2 and I'd get to a -1. And here's what I mean that sometimes the chart doesn't really give us what we want. Because I don't have a value for 0 here. It doesn't give it to me because this chart only goes by 2s and I'm only hitting odd numbers, so I'm just not hitting the 0s. But I do know that it's somewhere between -3 and -4. And actually on this one, if you were to guess that the y-intercept is -3.5, you would be right. So we can kind of conclude it from this. We have enough information to say that, sorry, not the y-intercept, the x-intercept. The x-intercept is -3.5. But hopefully you see what I mean, that the chart just doesn't always give you all the information you want. So we were able to get it here. We were able to conclude that it was right in the middle of -3 and -4 because 0 is right between -1 and 1. But you'll see in some other examples here how that just won't always be so simple. So let's take a look at number 2. Okay, right away, I'm good. I got the y-intercept. I know the y-intercept is -4 because it's just displayed right there. It's when x is 0. But I also want to find when the y is 0. Well, look, I don't know that. It's somewhere in between these two values. And it's not so simple now because this is changing by 3 and this is changing by 1. And so it's going to go 2/3 of the way this way, and so I have to do 2/3 of 1, and so you can kind of estimate what it is, but it's not straightforward, simple like we want it to be. And so when we get into situations like this, probably what you want to do is you want to just write an equation and then use the equation to find your intercepts. I think it'll make your life a lot easier. But let's keep going. Let's see if we could find any information from these other charts. All right, at number 3, they don't give me anything with a 0 in it, so I don't have anything free. But I can tell that 0 would just be the previous number right here. So let's just go ahead and put that, because these are all counting by 1, so if I go backward, I get a 0. So what's happening on the right side? Well, it looks like I'm adding a value because it's becoming less and less negative, and it looks like I'm adding 4 every time. So if I was to go backwards, I'd have to subtract 4, so I think that puts me at -21. Okay, so I think the y-intercept is -21. Now, where's the x-intercept? Not going to be so easy on this one. Because if I was to keep going down this chart, trying to get to when the y is 0, I would add another 4 and I'd get to 3. I'd add 1 to the 5 and I'd get to 6. And I'd be stuck in that situation where the 0 is somewhere in between these two numbers, and so I don't know for sure. So this is an example where the chart doesn't give me all the information. I would probably need an equation or to do some math here. Now there is some mental math you could do to probably figure this out, because you're only going to go a fourth of the way because you only want to get to 0. So what's a fourth between 5 and 6? And yeah, it's 5 and 1/4 is going to be your answer. But I'm trying to show you that that's maybe not the most efficient strategy. All right, let's head over here. And we can see these numbers are counting up from -6 by 1. And if we were to fill this in, we would get -1, 0. And over here, we can see that we are actually subtracting 5 every time. And so the next number would be negative 29, and the next one after that would be negative 34. And so we do have the y-intercept equals negative 34. But it's not going to be so easy to find the x-intercept. Because if I go back and I add 5 to this first term, instead of subtracting as I'm going the other direction, I get to positive 1, and I get negative 7 over here. And then once again, we have this weird situation where it's somewhere between these two, so I would need an equation. So I just want to point that all out to you to let you know, like, the table is sometimes useful and other times not so useful. So keep that in the back of your mind. You might need to have a little bit more work if they give you a table. And if they get some really tricky ones in class, I'm happy to show you some examples of what you really need to do there. But in my opinion, what you're going to need to do is just write an equation and use your equation to find your intercepts. So let's talk about how we do that from an equation. Well, we kind of already talked about that. Let's just recall real quick that the x-intercept is when the y is 0, and the y-intercept is when the x is 0. So you're just simply going to be plugging these values in. You're going to be plugging a 0 in for y to get the x-intercept. You're going to be plugging a 0 in for x to get the y-intercept. Let's do the x-intercept first. I have a 5x plus, I don't have a 0. I'm plugging in a, I don't have a y, I'm plugging in a 0 for it, equals 2. 5x plus 0 equals 2, because remember, I'm plugging in a 0 for y to find my x-intercept. Work this out. I get 5x equals 2. Divide both sides by 5. I got x equals 2/5. So I think my x-intercept is 2/5. Again, I can also write that as 2/5, comma 0. Another way of saying the exact same thing. All right, well, what about the y-intercept, right? Well, for the y-intercept, I'm going to plug in a 0 for y. And this obviously just turns to 0. And this is a really simple equation. You're left with just y equals 2. And so my y-intercept is 2. And I could also write it as 0, comma 2 in parentheses. Okay, I want you two to try the next two on your own. You're literally just plugging in a 0 for one variable, solving for the other. And that's how you're going to get your x and y-intercept. Go ahead and give these two a try. We'll check back when you're ready to check your work. Okay, here's my work for both of these problems, just so you can pause the video if you want to and just look over your work. But basically, pretty simple. I'm plugging in a 0 for y and then solving for x, plugging in a 0 for x and then solving for y. And I'm doing the same thing here, plugging in a 0 for y, solving for x, plugging in a 0 for x, and solving for y. That's all there is to it. It's pretty straightforward. All right, let's go to the next page. All right, on this one, I'm going to do the first one with you all, and I think you'll get the hang of this. This is pretty simple. When they say find your intercepts from a graph, all you're really doing is looking at the graph and saying, when does it cross the x and the y-axis? That's literally it. So if I go right here and I look and see, well, when does this thing, what's my x-intercept? When does it cross the x-axis? And it looks like it's doing that right here at 2. The coordinate, you could write it as 2, 0. Boom. When does this thing cross the y-axis? Right here at -2. So I could say the y-intercept is -2. Or I could give it a coordinate location, x value 0, y value -2. Boom, boom. That's all there is to it. So I want you to go ahead and try these other three on your own, and then check back when you're ready to check your work. Okay, so let's just go over these really quick. I have a y-intercept at +2, x-intercept at +2. Over here, it looks like I have an x-intercept at -1, y-intercept at -5. It starts to cover up the numbers, but remember, you can always just count 1, 2, 3, 4, 5. Over here, I have an x-intercept at -3, y-intercept at 2, and that's it. All right, don't forget to ask me at least one question at the end of the video. See you guys on the next one.